All right, so we're going to wrap up our conversation on infinite limits, and infinite limits weren't too bad where the limit approached infinity. What we are really concerned about is limits at infinity, okay? So the type of thing when you have the limit and then it's going to be some rational equation, so something over something else, as x approaches infinity. And here in a minute, we're going to do some where x approaches negative infinity, but first things first. Okay? So you're always going to have a numerator and you're going to have a denominator, and I'm just going to do some math notation here. Rather than writing out an entire function, I'm just going to say p of x, and that's going to represent a function. It could represent like x squared, or 3x minus 5, or 10x to the 5th minus 4x. It could be something really long, whatever, but that's going to represent a function. And then q of x is going to be there in the denominator. That could also that represent just a different function, okay? What we saw yesterday was if the denominator, well, not the deminator, the denominator grows faster than the numerator, then the ratio approached, anybody remember? If the denominator grew faster and faster and faster? Kirsten?
0.
Yeah, then the ratio approached 0. Then the limit of those two things approached 0. But if the numerator grew faster than the denominator, so if we had like 5 over 2, 20 over 2, 500 over 2, right? Somebody else, do you remember what that fraction approached? You should have this in your notes. If the numerator grew faster than the denominator, yeah, then the ratio approached infinity. So you can, if you can figure that out, which one grows faster, and you can remember these two rules right here, then you can solve these problems literally within 5 seconds. No graph needed, no algebra needed, just straight calculus knowledge, okay? So that's pretty cool. The only thing that we, I guess there's a couple things that we need to do is we need to learn which functions grow faster than other functions, okay? I think we saw something yesterday like we had an x squared versus like a 3x, right? I think we had something like that, and we graphed it. Does anybody remember which one of those grew faster, grew larger? Yeah, it was the x squared. In fact, that is true of any quadratic versus any linear. Okay? So if you have anything such as ax squared, and then over here you have bx, and we want to see which one of those two is going to grow faster, the quadratic always goes faster in the long run, okay? Right? Because at some point in time, if you think about which grows faster, the x squared, you're going to have some number times itself that's huge, like 1,000,000 times 1,000,000, okay? Versus like 2 times 1,000,000, okay? So I don't know, does that make sense in the long run? Would you like to see a graph of this? Sure, let's see a graph. It seems like I'm not sure about what's going on, Mr. Goddard. All right, so we're running. So let's see which one of these grows faster. We have y equals, we'll just say some small number, 2x squared, versus y equals, I'm going to put a pretty large number. I'm going to put 1,000 x. Now 1,000 x, oh my gosh, that is getting really big really quickly, right? Well, that's not that. The graph isn't really going to help us out there very much. So let's do some tables here. All right. So what if I look at when x equals 100 here, and I'll go down to this one. X equals 100. All right. So when I'm at 100, who's winning? The 2x squared or the 1,000x? The quadratic versus linear. When I'm at 100, whose y value is bigger? The 1,000x. Okay. What about 500?
It's the same.
Ooh, they're tied. The quadratic's caught up. What about 800?
Yeah, the one's larger.
1.28 times 10 to the 6. All right, that's so 1.28 times 10 to the 6. So 1, 2, 3, 4, 5, 6. So that's 1,280,000 versus what is it for the 1,000x?
800,000.
800,000. And guess what? That difference is only going to get bigger. Okay? So what I'm telling you here is quadratics grow faster than linear.
Quadratics?
Every single time. Now over the long haul, now in the short region we saw up until we hit 500, they were, the linear was winning. But over the long haul, that quadratic's going to win. So let's apply that knowledge here to a limit problem. So the limit, as x approaches infinity, of 1,000x divided by 2x squared.
That's supposed to be an infinity.
Oh, not is that.
Okay.
X approaches infinity. Is that what you were getting at? Okay. So you look at the top, look at the numerator, and you say that's linear because anything that just has an x term is linear. Remember in our function families. We look in the denominator. This is quadratic. Anything that has the highest power of x squared is quadratic. So we've got a quadratic in the denominator, a linear in the numerator. Who's going to win over the long haul as x approaches infinity? The denominator, the quadratic. Yeah, you're all saying the same thing, just different words. So since this is getting bigger, now Sarah, I'm going to give you time to work on that homework, okay? I want you to focus on the new stuff, otherwise you'll not know the old stuff or the new stuff. All right? So, denominator wins. I immediately know the answer to this problem, and so do you. It's 0. I could make this as ridiculous as I wanted. I could say, what's the limit of 100 billion? Let's see, that's 100 million. That's 100 billion x over 2x squared. Who's going to win? Who's going to get bigger as x approaches infinity? The quadratic. You're like, oh my gosh, that's a billion, and this is just multiplied by 2. Doesn't matter. Because think of it, we're going out farther and farther along that x-axis. Eventually, on our x-axis, we're going to hit 100 billion. We're going to hit 200 billion. We're going to hit 500 trillion. And when that's going on, the denominator is 2 times 500 trillion times 500 trillion. Meanwhile, the numerator is it's going to be 500 trillion times 100 billion. You see where I'm coming from?
Mm-hmm.
So the quadratic is going to swallow that one up every single time. Okay? Now what if it was reversed? What if it was flipped? Then it would be infinity. The limit as x approaches infinity of 2x squared, I'm gonna write something just not as crazy, just, 5x. It's going to be infinity because the quadratic is going to win over the linear every single time, okay? All right, now, let's see if we can reason this out. What about a cubic ax cubed versus a quadratic? It is going to be the cubic, because no matter what number I have there for the a and b almost like don't even really matter. What really matters is that x, because the a and b are a fixed number, but x is getting bigger and bigger and bigger and bigger and bigger, okay? So eventually at some point I'm going to have 1,000,000 times 1,000,000 times 1,000,000 times who knows, like 2 or 3 or something like that, or whatever. But over here I'm going to have 1,000,000 times 1,000,000 times another number. See what I mean? So every single time the cubic will win. And so now you're thinking like, I wonder if it has a fourth power, that's called a quartic, versus a cubic. Who do you think is going to win? The quartic, the one with the fourth power, or fifth power. So, and you can kind of play this mix and match game all day long. What it boils down to is whoever has the higher exponent there is the one that's going to win, so to speak, right? So we could do something like the limit as x approaches infinity of 3x squared divided by 2x to the 7th. I don't need no stinking graph formula or Desmos. Get out of here. Just need calculus in my brain. Which number is bigger? And to know which number matters, right? Does the 3 and the 2 matter? No. Nope. What matters is that 2 versus a 7. Who's going to win?
7.
Therefore, this ratio will go to 0. All right. So, that's all well and good. Let's talk about something kind of related to that. What about this one? The limit as x approaches infinity of 5x squared plus 10x minus 8 all over 9x plus 20. So you're like, oh, Mr. Goddard, is this going to be like all sorts of new rules and blah, 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 blah? And the answer is no. It's actually just as easy as the other ones. Okay? Because let's look at this numerator just as is right now. Who is the big dog on campus when it comes to this one right here? The 5x squared plus the 10x minus the 8. Which of those three is really going to matter as we approach infinity? The quadratic. This is the one that's really driving that whole numerator, okay? Yeah, the 10x is going to play a part, and that 8 is going to be like practically nothing by the end of it, right? But we're in the billions and the trillions and the quadrillions. Like, that minus 8 is not even matter. And the plus 10 is also going to be like, like a little speck on the graph, right? But this is the one that really matters, okay? What's called the leading term, okay? All right? So it's almost like this other stuff, I can almost just scratch it out, it doesn't even matter. What about in the denominator? Which of these two things is going to matter more, the 9x or the plus 20? The 9x. So really what I'm comparing is 5x squared versus 9x. No big deal. I know that off the top of my head. Who's going to win? The top one, the numerator, the quadratic, exactly. And when the numerator wins, our ratio goes to? See, now it wasn't too bad now, was it?
No.
So you don't even, you can put whatever, there could be all sorts of trailing stuff right here. Normally you want it to be in proper order, and that's why we normally want to write our polynomials from the highest exponent down to the lowest. Because then then we don't even have to figure out which one of these has the highest exponent. We just look at that term versus that term, and we're done. Mitzi.
Is it like, okay, so for the limit of x approaches infinity, what if there was like a number, like what if there was like, let's say -2, I don't know.
Oh, if it's approaching -2, that's right direct substitution.
Oh, okay. So
We've already done all that
Yeah,
sort of
yeah,
stuff.
yeah.
Mhm. We're looking, what we're asking today, and a little bit yesterday, is what about the long haul? What happens to this graph as time, as x goes on and on forever? Does it approach, does it approach infinity? Is it getting bigger and bigger? Or is it approaching 0? Is it getting smaller and smaller, so to speak? Okay, other question.
Oh no, I was trying to find
Okay. Good stuff, good stuff. What about, now this is gonna seem kind of strange. What if I did this thing? Limit as x approaches infinity. Almost the same exact problem. 5x squared plus 10x minus 8 all over 9x plus 20. But, here we go. There's a negative right there in front of the 5. Would that make any difference? Let's think about this. What number are we approaching? It's ignoring that -5, so we've kind of established. Of those three terms, the -5x squared to the 10x to the minus 8, which one of those is the most important for this numerator? This one, right? So I'm not even going to look at those other guys. I'm looking at this one. Now as x gets larger and larger and larger, x squared is going to be a positive number, right? So this is a positive number. And we're multiplying it by -5, so times a negative number, yes? So this numerator is not actually approaching, getting larger and larger and larger positive, it's actually getting larger and larger and larger, so to speak, negative, right? It's going to be -5 billion, -5 trillion, -5, I don't know, dodecagillion, no, whatever. So yeah, so this numerator, if I kind of write it over here, that's sort of approaching negative infinity. You see what I'm saying? Now the denominator, who cares? It's 9x, this one's bigger, okay? So it's a really, really large negative number over, well I guess we could say this is really negative, and this number down here is positive, okay? So it's going to be a negative number over a positive number. So this is actually going to approach negative infinity.
If the bottom one was a -9x, would it just approach regular infinity?
Yep, because it would cancel. I'll show you that here in a second. So y equals 5x squared plus 10x minus 8 divided by 9x plus 20. Alright, so what we're asking is what happens as x approaches infinity? So as the x values get larger and larger and larger, well, it looks like it's getting, the y values are getting larger and larger. And in fact, if I zoom out, y values are getting larger, y values are getting larger, y values are getting larger. See, yeah, so definitely approaching positive infinity. But the minute I stick a negative in front of that 5,
other side.
yep, as the x approaches infinity, we see the y values are approaching negative infinity. What Robert asked was, what if you stick a negative in front of that 9? And you're exactly right. The way we can know that without even messing with Desmos is we can think about it like this. As x approaches infinity, the most important term is the -5x squared. The most important term down here is the -9x. I know that x squared is bigger than x, so I know I'm approaching infinity, plus or minus. Now I've got to figure out, is it approaching positive infinity or negative infinity? And so I know, well, x squared, that term's always going to be positive, because a positive times a positive is a positive. But that's a negative right there, so this is going to be negative. with the negative 9x, x is gonna always be positive, but I've got a negative right down there. So negative times positive is always gonna be negative. So I'm always gonna end up having a negative over a negative situation, which would end up being a positive. Okay? Let me have y'all come up with a similar question here. So come up with a question here for me. The limit as x approaches infinity. What do you want in the numerator? Just so we'll kind of build it together. Sarah? 7x cubed, that's good. Kirsten?
Minus 5x, that's all I can think of.
Minus 5x? Good. Mitzi, denominator. And Robert?
Plus 8.
Okay. Alright, all together class, who's gonna win? Numerator or denominator? Numerator, okay? So therefore, this is going to approach
Wait, hold on. What?
who's gonna win?
Infinity. Oh my gosh.
Numerator wins versus denominator, so we're gonna approach infinity. Okay?
Oh my gosh, I thought I was so wrong.
Alright? Now, what if there was a negative right here? Negative infinity. What if there was a negative right up here? Negative infinity. What if there was a negative on both of them?
Positive.
Positive infinity. Okay, I think we're doing pretty good.
So
Okay?
if one of them is negative, then it'll be negative.
Now, that is a great sentence. If one of them is negative, then the answer is going to be negative infinity. Okay? But if that's the only thing that you pull away from today, you're going to get half the problems wrong. Okay? Because I do want you to be able to think through the analysis. Okay? Where if one of those is negative, you think this, obviously this is going to win. And then this is a negative, or sorry, a positive times a positive times a positive, which is a positive, and the 7 is positive. So you just sort of think about that term. That's always going to be positive. And down here, x is a positive and 9 is a negative, and so therefore that's a negative right there. And so a positive divided by a negative would be a negative. Okay? Now the reason I say you have to kind of do that analysis, okay, is because what I'm going to do now is I'm going to change it up a little bit. Okay? So watch this. The limit as x approaches negative infinity of the same, we'll do 7x cubed minus 5x over 9x plus 8. I'm going to do this maybe 3 or 4 different ways. So let's do, and y'all write it down too on your paper, because if I just erase it and stuff like that, it's helpful for me, but that's not helpful for you. So negative 7x cubed minus 5x, 9x plus 8. So a negative up there, everything's positive, and then limit as x approaches negative infinity of 7x cubed minus 5x of negative 9x plus 8. So I'll give you a second. We're going to write all 3 of those down. One of them where there's a negative in the numerator next to that term, one of them where they're both positive, and one of them where we've got a negative down here. It's some good analysis I feel like that we're doing. So let's go with what I would call maybe the easy one, and that's the one where there's no negative signs in front of here, okay? So we're going to look at that first term, so we know that's what my electrical engineering teacher would call the 500-pound gorilla in the situation here, all right? We got the 7x cubed, and then we got the 9x. Now, as x approaches negative infinity, this x cubed means we have a negative times a negative times a negative. Would you all agree with that? See, as x approaches negative infinity, we're going that way. Then this number right here is going to be like negative 50 times negative 50 times negative 50. Now what's a negative times a negative times a negative? It's a negative, okay? So the x cubed is a negative, the 7 is a positive, so we know that this term up here is always going to be negative, right? Now in the denominator, 9 times x is more and more negative, so x is negative, 9 is positive, so this term right here is going to be negative. So the numerator is always negative, the denominator is always negative. Negative over negative is a positive. So I'll see that's positive infinity. Going up here, look at the first one where the negative is in front of the 7. Now I've got an x cubed term over a linear term, so I know that x cubed is going to win. So I know my answer is going to be infinity. The only question now is it positive or negative? Okay? So thinking this through, negative infinity, so it's cubed. So a negative times a negative times a negative is negative, but then times this negative right here. See what I'm saying? So if you need to write it all out, negative times negative times negative times this negative, so positive. Right? So we have a positive in the numerator all the time. In the denominator, 9 times x. X is always negative, it's a positive times a negative, so it's going to be negative. We have a positive in the numerator, negative in the denominator. Positive over negative is a negative. So sorry, that's what I was saying a little bit earlier. If you just say, oh, so if all you said was, if there's one negative, then it's going to be negative, or what? Then it's like, not totally true, because it depends on if x is approaching negative infinity or positive infinity. It depends on whether or not this number right here is odd or even, right? Because if it's an odd number, negative times negative times a negative, an odd number of times, then it's going to end up, then this is going to end up being negative. If it's a even term, then all those negatives cancel each other out, right? And they clash and they end up being positive. So it's a little more complicated. That you really just have to do the analysis. So let's talk about this class. As x approaches negative infinity, I know x cubed over x, I'm approaching infinity. But let's see, a negative times a negative times a negative is a negative, and I have a positive here, so negative times positive is still negative. Down here, the x term is negative, and I'm multiplying that times negative 9, so it's a negative times a negative, positive. So negative in the numerator, positive in the denominator. It's going to be negative.
So basically, if it's a negative infinity, the negative carries on to an x. So you know what I mean?
If that's all you take away,
No,
then
no, no.
the answer is no.
No, that's not all taking away, but like simplifying the part of like, okay, so if it's a negative, if it's x, so it's like, let's say like the problem like negative 9 times x, and then the.
You're telling me that, is that x always going to be, am I going to treat that x as negative?
No, when it's like negative infinity. You know what I mean?
Mm-hmm.
Would it be that, or would it just be like?
If you're looking for like a shortcut to go from just looking at the negative infinity and looking at what, there is no shortcut. You have to do the analysis for which I'm walking you through the process here. Okay, I know I know that that's the human brain's way, is trying to make pattern out of chaos and things like that. But it has. You have to, number one, ask who's going to win, numerator or denominator. Then you have to ask what, and if it's infinity, it's numerator. Then you have to ask what's going on with that x term. Is that x term going to end up being positive or negative? And then you have to say what's the coefficient? Is that positive or negative? And you've got to multiply that in your mind and figure out whether that product is going to be positive or negative. Then you do the same analysis for the denominator, look at the x term, and figure out if it's going to end up being positive or negative. Look at the coefficient, see if it's positive or negative, multiply those two together, figure out whether it's positive or negative, and then compare the numerator sign, positive or negative, with the denominator sign, positive or negative, and then figure out, and that's going to tell you this. There's no other way around it.
But like, okay, if you still do that, if like the way, like, you know how you do like the x times the x times the x,
Mm-hmm.
and so if it's a negative infinity, then you would be assuming that the x is negative when you do the pattern.
Right, okay, yeah, so you're saying like, why do I know that it's a negative times a negative times a negative?
Yeah.
Right? Because this question is asking, what is happening as x is approaching negative infinity? So the numbers that I'm interested in are way the heck down that way. Negative 1,000,000 times negative 1,000,000 times negative 1,000,000, okay? That's why I'm putting, and maybe if this is what you're asking, then the answer is yes. You're asking, why do I put negative, negative, negative right here? And the answer is because this problem is asking as x approaches negative infinity. If this had been as x approaches positive infinity, then it would have been no problem. It would have been a positive times a positive times a positive. So this is positive, and that would have been a negative.
That's what I'm trying to ask. Does negative infinity, like, it determines what the x is going to be basically? Not.
Yes.
Yeah, that's what I was trying to like.
Yeah,
get
if
at.
that's your question, then the
Yeah.
answer is yes. That's a good question.
'Cause
And
I was like,
It's like,
I didn't know how to word it.
now let's this is a great one. Y'all came up with a really good one. Let's do that same thing, but with the x approaches positive infinity, so you can kind of see by way of comparison. Okay. So we'll do the limit as x approaches positive infinity of negative 7x cubed minus 5x over 9x plus 8. So we're doing our analysis. Who's going to win, numerator or denominator? Numerator. So I know the answer is infinity. Now it's just a matter of whether it's positive infinity or negative infinity. Okay? Well, since I'm going as x approaches positive infinity, all my x values that I'm really interested in are positive. So this right here is going to be a positive times a positive times a positive, which is going to be positive, times this negative number right here. Alright, so negative times positive times positive is going to be negative. In the denominator, my x's that I'm interested in are always going to be positive. So that's a positive, so that's a positive. And so a negative over a positive would be a negative. We'll do another one here, and we'll do another one, and then we'll do another one. So, as I'm going to do, as x approaches positive infinity of, let's say, 4x squared plus 3 over negative 5x minus 6. And then, same problem, limit as x approaches negative infinity, 4x squared plus 3 over negative 5x minus 6. I'm going to give you 2 problems, 2 minutes, see if you can come up with an answer. Ready? Go. You got an answer? You gotta commit. You gotta commit to an answer. You committed? Was that? Okay, we got numbers. We got positives and negatives. All right, good job. Only took us 1 minute. All right, so who's gonna win, numerator or denominator? Numerator. Okay. So we know the answer is infinity. It's just a matter of whether it's positive or negative infinity. So as I'm looking at this one, as x approaches positive infinity, what sort of numbers am I looking at? Positive numbers, okay? So positive times a positive, and then another positive. That's all positive right there.
Yes.
Agreed? What about in the denominator? X's are all going to be what type of a number?
Positive.
The -5 is clearly a negative.
So it's a negative.
So we have a positive over negative, which is
A negative.
negative.
So I have a question.
Sure.
Not about that, but like, let's say the negative is like outside of both numbers.
Oh, if the negative's out, oh, if the
Yeah.
negative's like right out in front,
Yeah.
right there, okay? Then just ignore it and do all of your analysis and then multiply it by the negative.
Both of them?
No. Like, what I'm saying is cover it all up, act like it's all of this times a -1, okay? And so do all of your analysis, and with that one, -1 covered up, and we came up with, oh, it's negative infinity, right? But then it's like, surprise, multiplied by -1,
Ah,
Comes
okay,
positive.
Okay.
does that make sense?
Yeah,
Yeah.
it does, but
Okay.
it's funny.
But okay, so anyway, but that's the easiest way of processing that type of thing.
Okay, cool.
Looking at the denominator, we have 4 times x squared. Now as x approaches negative infinity, what type of numbers are we dealing with?
Negative.
Negative. So x squared is a negative times a negative
Equals a positive.
equals a positive, and 4 is always positive, so this ends up also still being positive. That's kind of cool. That's always going to happen when you've got
Totally.
even powered right there. Now in the denominator, that -5 is we have an x right here. What type of numbers are we dealing with?
Negative.
Negative. But the -5 is also,
So negative.
right? So negative times negative,
Is a
positive. Positive over positive, you should have
Positive.
positive. This, by the way, reminder, was negative because I didn't have that for them. So did y'all have negative over positive?
Yes.
Good job, good for you.
Thank you.
There is one case, though, that we have not dealt with. The very important case of when an unstoppable force meets an immovable object.
Oh, okay.
Think about that, Robert. You ever heard that phrase? My favorite, I mean, sort of, it's in The Dark Knight. So, Joker is the, I don't know, probably the unstoppable force. Batman will be the immovable object. What about this? Limit as x approaches infinity. Y'all are gonna be like, oh my gosh, Mr. Goddard, this is 3x squared plus 5x plus 7 over, wait for it, 4x squared plus 6x plus 8. Who's gonna win?
The denominator.
Why?
Because now we have to put a factor of which of the.
Oh, because of what?
No, wait. Now you have to see how, like, which one's the number is bigger. I don't know.
Yeah, oh yeah, right, okay, so I mean, it's in proper form, right?
Yeah.
So I got a quadratic up here, so obviously clearly the 3x squared is the big dog. So this is pretty much almost goes to 0. I'm not goes to 0, but this is pretty negligible, right? And this one down here in the denominator, the 4x squared, everything else is pretty negligible, okay? So you're like, Mr. Goddard, it's a tie, right? So it literally goes to, it's like 3x squared over 4x squared, okay? That's almost the same problem. Now if I had 3x squared over 4x squared, you'd be like, Mr. Goddard, those x squareds would cancel, and it would just approach 3 over 4. And the
Oh,
answer
wow,
is,
that's
yep,
cool.
it is. That's what happens.
Uh-huh.
If it's a tie, in baseball, tie goes to the runner. In calculus, tie goes to the ratio of the leading coefficients.
So let's say for a number like, never mind, I can't ask a question on the homework, right?
Hold on. Tie goes to the ratio of the leading coefficients. And the leading coefficient is obviously the number that's multiplied by the term with the highest power. Okay, question, Mitzi.
Can I ask one from the homework?
You can ask one that's like the homework, but you got 1 minute, go.
Okay, so for number 15, it's 2x squared over x squared plus 4. So would it be, since 4 is basically like, it's whatever, then wouldn't it be like 2? No? Yes?
Ooh, I like it. So, I'll write that one down. The limit of 2x squared over x squared plus 4 as x approaches infinity. So you said x squared term, that's a tie situation, Mr. Goddard. You are correct.
It's 2 because also if you look at the graph.
Yeah.
You see it, oh.
So you're saying the ratio, yep. 2 over 1, yep, is 2. So I'll up at 2 over 1. Yeah.
I'm just kidding.
It actually, yeah, no, but I'm serious. That's how you know that there's and that's what the graph looks like. I'm glad I brought this up. This graph right here would look like there's a horizontal asymptote at 3/4, and it would approach 3/4 as x approached to infinity.
I was about to ask what happened to the 4, and then I was like, oh yeah, it doesn't matter.
Right? Now, I don't know if there's any other ones like that as x approaches infinity.
Good question, Nancy.
That is.
Wait, so we use the steps, and it's either the infinity or the 0? Like, we use the rules to figure
No,
it out?
no.
Yep, it's those 3 rules. If the denominator grows faster, then we're approaching 0. If the numerator grows faster, then it's approaching infinity. Actually, sometimes we saw that it could be approaching positive infinity or negative infinity, right? Depending on the pluses and the minuses, okay? Right? All of those ones that we were just dealing with before, the numerator was always winning. If the denominator wins, it's 0, no big deal. You're not going to have a positive or a negative 0. The only time that you're really worried about that plus or minus analysis is when you've got the numerator winning because you've got a plus or minus infinity. And if it's a tie, it's going to go to the ratio of leading coefficients.
What if there's no denominator?
There's always a denominator, it might just be 1.
Well, like,
Because the rules are just followed.
Go ahead.
on number 16?
The denominator is 1.
The denominator is 1 then?
Yeah,
So then it'll be infinity, but then we have to figure out if it's negative or it's positive?
that's correct.
Okay,
You can also look at the graph.
okay.
All right. If you have any questions, please put them in the comments below. See you next time.